Well, welcome back. I'm sure you had not a lot of trouble with video quiz 4, but I'm going to try to get you ready now for another video quiz, which will be called VQ number 5. And it just tests a little bit more your understanding of subscript notation with the Fibonacci sequence and perhaps the Lucas sequence. So let's take a look at some questions, and you'll be able to get yourself prepared for your next video quiz that's coming up very shortly. Okay, so here we go. Question number 1. All right, if f sub n is the Fibonacci number 987, then the value of n that should be under the subscript right there where the f sub n is, where the n is, the subscript should be what? Well, you can see that 987 is right here, and it is the 16th Fibonacci number. So n has to be 16. So it would be f sub 16, or the value of n is 16. Okay, great. Let's go on. If f sub n exists such that n is 21, then the Fibonacci numbers value which corresponds to f sub n minus 11 is, well, again, if I put down f sub n minus 11 and I put 21 in for n, it'd be 21 minus 11, or f sub 10. So looking for f sub 10 then, it will be what? 55, okay? No problem, right? Let's go on. Let's look at C. If f sub n exists such that n is 14, then the Fibonacci numbers value, which corresponds to f sub 2n minus 11, is what? Well, if I write down f sub 2n minus 11, and I put 14 in for n in the subscript, okay? 2 times 14, of course, is 28, and 28 minus 11 is 17, right? So this should be Fibonacci number 17, which of course is 1597, which would make your answer choice 4. If f sub n exists such that n is equal to 3, then the value of n, or the f sub n notation, which correctly represents the Fibonacci number 610, would be what? Well, 610 is the 15th Fibonacci number, right? And which of these subscripts would be correct to give us the value 15 for the subscript if n is 3? Well, I believe you can see that f sub 5n would be the correct answer, because if you put 3 for n in for 5, 5 times 3 is 15, so that would be f sub 15, which of course is the value 6/10. If f sub n exists such that n is equal to 7, then the value of the Fibonacci number, which is represented by the notation f sub 5n minus 18, is what? Well, I just put 5n minus 18 down here as the subscript. I replace the n with a 7. It'd be 5 times 7, which is 35. 35 minus 18, right, is 17. So the answer should be 1597, choice 4. Which notation statement is true? This is a little harder. What I suggest you do on some of these types of weird questions is pick a value for n and try it. Like pick a value of n as 6 or something, and put it in and see if it works. So for example, in the first one, if I were to let n equal 6, what does number 1 say? It says f sub what? 6, which is n, plus f sub 8, would be n plus 2, right, is equal to f sub 8. Well, if I were to add f sub 6 together, the number 8, and the number f sub 8, which is 21, if I add 8 and 21, I get 29. That certainly isn't f sub 8, which is 21, right? So you know 1 can't be the correct statement there. All right, let me erase these all off so they're out of our way. Let's look at choice 2. All right, if we're using n equals 6 again, what does statement 2 say? It says what? F sub 7, I believe, right? 6 plus 1 would be 7, minus what? F sub 6, right? Should give me f sub n minus 1. Well, f sub n minus 1 would be f sub 5. So let's see. If I take f7, 13, and subtract from it f6, which is 8, do I get f5, which happens to be 5? I do, right? So it appears that statement 2 is true. So it looks like it could very much be the answer. Look at the diagram again. Let me get rid of all this stuff. Let's see if the next statement I make on here makes any sense. Is f sub 5 equal to 5? Yeah. Is f sub 13 equal to 377? No. F sub 13 is 233 right here, right? So that isn't correct. Now, wait a minute. Look at number 4. If you double n, the subscript, is it the same as adding 2 to it? Well, in order for it to be a true statement, it has to be true all the time. If we let n be 6 again here, like we were before, is f sub 2 times 6, or f sub 12, the same thing as f sub n plus 2, 6 plus 2, which is 8. Is f12 the same thing as f8? No way, right? f12 is 144, f8 is 21. They are not equal to each other. But just for curiosity's sake, or just to have you think a little bit, is there a value for n where the statement for would be true? Well, as it turns out, if n was equal to 2, right? N was equal to 2, okay? Then it would work. Why? Well, if n is equal to 2, f sub 2n would be the same thing as f sub 4. F sub n plus 2 would be the same thing as 2 plus 2, which is 4. So f4 would be equal to f4, so that would be okay. But this only works when n is equal to 2. It doesn't work for any other value, right? So it's not a true statement. Only in one case is it a true statement. So it appears then that this wacko statement right here is correct. It should be number 2. And remember something. This is basically saying what? Take a Fibonacci number, 1 away from f sub n, 1 past it, subtract the Fibonacci number away from it that we started with, all right? Should we get the Fibonacci number that's 1 before it? Yes, we should, okay? So obviously, again, that's another way to look at that statement. We know it is definitely true. All right, what is a prime number? Well, you probably haven't thought about prime numbers for a long, long time. Maybe 7th, 8th grade, but then maybe as a freshman in high school. But a prime number, you must remember, is a number that is a counting or natural number, first of all. Has no fractions or decimals in it, okay? And it has to be greater than 1. Now, a prime number, okay, has to be greater than 1 because it can have no other numbers that except itself or 1 that can divide into it. Now, why can't 0 be a prime number? 0 can't be a prime number because everything can divide into it and you'll still get 0, right? So, I mean, it divides into it evenly. So 0 is totally out of the question. The only number that can divide into 1 is 1. So 1 is not a prime number either, okay? So prime numbers actually are defined to be or said to be numbers which have as multipliers or factors. A factor is a multiplier, okay? So if a number is prime, the only multipliers that will multiply together to give you that number are the number itself and 1. Example, look at the number 2. 2 has as its factors only 2 and 1 because 2 times 1, those are the only two numbers that will multiply together that are natural or counting numbers that will give you 2. There are no other numbers that will do that fit for 2. Let me take the number 14, for example. Is 14 a prime number? Okay. Well, let's see. Doesn't 2 times 7 give me 14? It does. But does it have other numbers that multiply together to give us 14? Well, how about 1 and 14, right? So 14 is not prime because it has multipliers, or these numbers, 2 and 7, 14 and 1, are called factors of it, which multiply to give you 14. Remember, prime numbers only have factors of themselves and 1. What's the next prime number after 2? Well, if you can recall from middle school or high school, it's 3. 3 has as its multipliers only itself, 3, and the number 1. No other numbers that are counting or counting or natural numbers can be multiplied to give you the answer 3. How about 4? Is it prime? No, 4 is not prime because 4 can be written as 2 times 2 as well as itself times 1. So it is not a prime number. So if there's no number that goes into the number in question, except for 1 and the number itself, no other number divides into it evenly, we know the number's prime. Now, is the statement I'm about to make true or false? All prime numbers are odd. That means they end in 1, 3, 5, 7, or 9. Well, it turns out, if you think about it, that statement is false because why? Because the smallest prime number actually is 2. However, every number that is prime above 2, okay, is odd, okay? The reason that is why? Any even natural or counting number that you can think of, let's try 32. Isn't it divisible by 2? So it has as its factors, one of the set of factors anyway, 2 and 16, right? It doesn't only have factors of 32 and 1, does it? So all even numbers above 2, all natural numbers or counting numbers above 2 are not prime. They're called something else. They're called composite. Composite. Now, a composite number isn't prime. It has factors other than itself or 1. Okay? So, the only even prime number is 2, right? And all the rest of numbers that are prime have to be odd natural numbers. However, there are odd natural numbers or counting numbers that are composite. For example, think of 39. 39 is 3 times 13, right? It has factors other than itself or 1, 3 and 13, for example, right? So, therefore, you must realize that after you have considered a number to be odd, or figured that out to be odd, or know that it's odd by just looking at it, it could be a prime number or a composite number, okay? But the only even prime is 2. Now, with that little bit of background, okay, about what a prime number is, let's take a look at the next question, okay? What Fibonacci numbers up to n equals 12 are prime numbers? Now let's see. N is equal to 12, it said. Well, 144, is it prime? Is it divisible by anything except itself or 1? Sure, it's even, right? 2 will go into it. So that's not true. 144 is not prime. Now let's look at 89. Can you think of any number which will divide evenly into 89 except for itself, 89, or 1? Well, as it turns out, there isn't one. So this is a prime number. How about 55? 55 is odd. It could be prime or it could be composite. But I think you can see that 55 can be divided by 5 or it can be divided by 11. So this is composite. It's not prime. Okay. 34 is even. So it's composite, not prime. 21 is odd, but it's divisible by 3, right? So therefore 21 is composite. How about 13? Can you think of any number that will divide evenly into 13 except for 13 or 1? No, you probably can't. So it's prime. 8, definitely composite because it's divisible by 2. 5 is definitely prime. And 3 is definitely prime. And 2 is definitely prime. So what's your correct answer up here? Well, 2, 3, 5, 13, and 89 are the only numbers up to n equals 12 in the Fibonacci sequence, which would be considered or be called prime numbers. We're going to talk a lot about prime numbers here in this class, particularly in our next class when we get together. So get ready. You're going to have to know a lot about prime numbers. Okay, let's go on. Now, we have reviewed this material again involving the subscript notation, okay? So I'm about to ask you to once again do another video quiz, and you're going to do video quiz number 5, okay? Video quiz 5. So I would like you to attempt video quiz 5, all right? And please text me your answers to video quiz 5 after you have completed them, okay? Now, there will still be more material we will be discussing today with this class, so please be aware of that. So we're going to come back and watch yet again another video. So I will see you all very shortly, and you take care, and we'll talk to you soon.